And this is graphing square root and other radical functions. There's not a lot to this. If you know what the basic curves look like for quadratics and cubics and radicals, cube roots and square roots, then you're set. Because all we're going to do is translate these functions. The first two, y equals x squared and y equals plus minus square root of x. First one's a parabola opening up. Second one takes the shape of the parabola opening to the right. Alright, because these are inverses of each other. Is the first one a function? Yes. Second one is not a function because it does not pass the vertical line test. Now, down here in red, we have y equals x squared, but it gives you a restriction that x must be greater than or equal to 0. So if that's the case, then you would only graph the right side of the parabola. Alright? Same thing over here. If I didn't have the plus minus, then it would just be the top half. Now they are both functions.
Wait, how did you do the last graph?
How did I what?
How did you do the last graph?
The red?
Yes.
It's just like this one up here, but if you don't have plus minus, you're only doing the positives of square root x, so it would be right here. It would be the top half. If you put the negative in with it, that's the bottom half.
When would it ever open to the left?
If I had a negative in with the x. Okay? So if this were y equals square root of negative x, then we'd take that shape.
If that one were less than, then you would go on the other side.
Less than or equal to 0, you would go on the left side, yeah. Okay. And cubics. X cubed takes that shape. Again, we're not going to get too exact, but if you want to get exact, you can always do a table of values and see how close we are to the actual shape. But that's the curve it takes. And if you have the cube root of x, it just flips. So it's going in that direction. Okay, and they are both functions, and your domain and range for each of them, for a cube root and a cubic, is what? All real numbers for domain and range. Question. So if you know those 6 curves right there, you're set. Alright? First example, all we're doing is translating. So this is going to work off of the second red graph up there, y equals square root of x. All we're going to do is translate. What's your starting point up here? 0, 0. You can't go into the negatives for the x values. You got to start at 0, 0. So we're going to translate right, left. This one's up and down. If the number's being added or subtracted outside of the radical, that's a vertical translation. So square root of x plus 2, I just moved the whole graph up 2 units. So here it is. Square root of x minus 1, I just moved it down 1, and there it is. Easy enough? Alright.
Could you not change it?
Yeah. Now the next example is the horizontal translation.
Okay.
Right here, y equals square root of x plus 3. Now be careful here. This is just like we were doing absolute values. Whatever makes the middle 0 is the way you translate it. So what's going to make your middle 0 here? Negative 3. So that's why I moved back 3. Also, you should know that the domain x must be greater than or equal to negative 3. Couldn't be negative 4, then you would have a negative under the radical. Okay? And this one moves it forward 2, because my domain is x is greater than or equal to 2. So there it is.
How can you tell your domain is it?
whatever, you set the inside equal to 0, and then just say x minus 2 must be greater than or equal to 0. And when you add 2, you get x is greater than or equal to 2. Okay?
And why do you go horizontally this time?
If the number is inside the radical, added or subtracted inside the radical, that's a horizontal translation. If it's outside the radical, that's a vertical translation. Alright, now this is both and a reflection. Alright, it should be a horizontal translation, back 1, vertical, down 3. So I went back 1, down 3, start at 0, 0, back 1, down 3, and the negative reflects it along the x-axis. So instead of opening in this direction, it opens down.
Because of what?
Because of the negative. Don't worry about the 2 right now. Unless you want to get exact, again, you can make a table of values, and the 2 will just tell you how wide it opens or how narrow it opens. But I'm not too concerned about that right now. I just want to see that you know how to translate them, back 1, down 3, and reflect it along the x-axis. Make sense? And this sort of goes back to what Corey was asking. If there was a negative in front of the x inside the radical, that would cause it to open towards the negatives. Okay?
You just call me Corey.
See now.
That was weird.
Cubic. Let's go back for a second. Any cube root. Any cube root function. We're going to focus on whether it's a cube or a cube root. We're going to focus on the point 0, 0. That's the point I'm going to translate. Same thing I just did with square roots. I translated 0, 0, here, 0, 0, all throughout. Alright, so translate the point 0, 0. We know what a cube root function looks like, bottom right. And here, same thing. Under the radical, tells me to move it left 3. Outside the radical, down 1. Takes the same shape. Don't worry about how the 2 is going to affect it. Good? Alright, one more.
Wait, why does it go this way and not the other way?
What other way? Your only other way would be here.
Yeah.
Is that what you're answering?
Yes.
It would do that if 2 were negative. It would flip.
Okay.
Okay, so look back at the first example we did and see what shape any cube root takes. But if it were negative, that would flip it to make it go this way. Alright. And the last one. If you can simplify under the radical, you need to do it to make it easier to graph. So we're going to, the original problem says to rewrite y equals square root of 4x minus 12 to make it easier to graph. You should be able to look at this and tell that we can factor a 4 out of 4x minus 12. Now look at the square root of 4 times x minus 3. And then I can take the square root of 4, which is 2. And it's a square root function. So I know to shift 3 units to the right, and it opens up. So at any point that you can simplify under the radical, you need to do so.